Now let's look at the last exercise, which is exercise 6. Okay, so now you have a rectangular loop. So this one is your rectangular loop. Okay, and it is situated in the xy plane, parallel to the xy plane. Okay, and it moves away from the origin at a velocity this one. Okay, so this loop will move from the origin. Okay, move in this way at this velocity, and the direction is positive y. Okay, in a magnetic field given by this one. Okay, so now you have magnetic field, okay, which is this one, in the positive z direction. Okay, just imagine the flux coming out. Okay, like this. Okay, flux coming out. And if the r is 5, okay, determine the current in the loop. Okay, so you have to find the current in the loop. So you have to redraw it here again. Okay, so again I draw it in 2D also. So I draw it in 2D. So this is the direction x, direction y, and I assume the z, positive z, is pointing out from the page. And this is my loop. Okay, I have 1, 2, 3, 4 moving in these directions, and the length is 2 meters. Okay, and here is 0.5. So according to the question, the magnetic flux density is in the positive z direction. That's why I draw this thing. And according to the Lenz's law, okay, the generated current should flow in this way because it should generate another magnetic field that is opposed to the original magnetic field. Okay, so the red one will represent the direction of my current. Okay, so since there is velocity here, okay, so it is motional EMF, which means that you have to use this equation. Okay, so in this question, okay, you have 4 dl. What does it mean by 4 dl? Okay, you have 4 length. Okay, this is the first length. Okay, and this is the second length, and the third length, and the fourth length. Okay, so I put here, you have 1, 2, 2, 3, 3, 4, and 4, 1. So we have to do it one by one. We have to find the voltage generated at each side of the loop. Okay, in the previous question, we no need to find the voltage at the other side. Okay, we only need to find the voltage on the moving side because there is only one sliding bar here. Okay, if you look at this one, only this one is moving, and all these things, they are static. That's why we no need to find the generated EMF here, but we just need to find the generated EMF here. But for this case, 4 of them, they are moving at the same time. That's why we need to determine the voltage generated at each side. Okay, so okay, we look at the side 1, 2. This is a side 1, 2. Okay, this has been given, this has been given. Okay, and for the DL, okay, we have to look at this one. Okay, current flow in the negative x direction, right? Negative x direction. So this one is dx, negative x. Since current flow in this way, okay, our integration interval should be from here to here. Okay, and here I assume this one is from negative 1 until positive 1 to make the length to become 2 meters. So I integrate from negative 1 to 1. Okay, just to make sure that it is 2. It is 2, and I perform the integration. Okay, I will find that this one should be negative 2 exponential negative 0.1 y. Okay, so this y is depend on the location of the sliding bar. Okay, so since this is located at position 2, so I replace the 2 here, and I will get this one. Let's look at the length 2, 3. Okay, 2, 3 is here, 2, 3 is here. Okay, so we use the same formula. This is your velocity, this is your b, and when you look at the length 2, 3 is here, and the current is flow in this way, which is in the negative y direction. So here is negative y and dy. Okay, and the length is from 2 to 2.5. Okay, 2 to 2.5. Okay, so for this case, okay, when you look at the cross product from these two things, you will get x, and here is negative y. When you perform dot product for these two directions, you will get 0. So we no need to do any calculation, integral calculation here. The answer will be 0. Okay, so this is for length 2, 3. Okay, we move on to the length 3, 4. This is the length 3, 4 from here to here. Okay, same thing, and the direction will be negative y. So y, negative y. Okay, so for length 3, 4, okay, the current flow in the positive x direction. 3, 4 is here, positive x direction here. Okay, so dot product. Okay, and the interval for the dx, you have to look at here, dx. Okay, current flow in this way. Okay, in the negative, in the positive x direction. So you have to integrate from 0.3 to 0.4, which is from 1 to negative 1. Okay, so here will be 1 to negative 1, and when you replace the y into it, okay, you will get your voltage is equals to this one. And for the side 4-1, it is similar as the side 2-3. Okay, same thing, so you can check yourself, and the answer will be 0. Now we need to find the total V. Okay, the total EMF here. So the total EMF here will be, okay, the dimension here. So this is the one generated at point 1, 2. Okay, and this is 3, 4. So if you combine them, so it will be negative 1.558 minus, okay, you have to follow the loop, minus the negative 1.638. So you get 0.08. Okay, this is your voltage, and when you need to find the current, you just divide the resistance, and you will get negative 0.016 ampere. So this is the exercise 6.